Hello, this is your special education virtual content specialist with the 7th grade math lesson for April 28th. This lesson, as with all other lessons, can be found on TeachHub. For each lesson, we provide the title, the focus question, and the learning objective, including standards and objectives for each lesson. Additionally, we provide guidance for using this resource, including instructional and technology guidance, implementation guidance for the lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging with students with disabilities and multilingual learners. 7th graders are working on Unit 8, Probability and Sampling, Day 8, More Estimating Probabilities. How can we compare probability estimates based on conducting an experiment many times to the actual probability? The introduction has 3 questions, and it will ask students to choose whether they think each event is either likely, unlikely, or equally likely, unlikely. To provide students with disability support and give them conceptual processing, you can review an image or video of weather forecasts in order to activate prior knowledge of the context of the problem. Additionally, as shown in this video, I've converted this Pear Deck slide into 3 separate slides, and to make it go quickly and analyze what students know about likelihood, I made them each into Pear Deck choice slides, so that they can quickly choose a response, and then we can have the discussion piece right after we see what other students have voted. So for question 1, if the weather forecast calls for a 20% chance of light rain tomorrow, would you say that it is likely to rain tomorrow? So students should choose unlikely, and in the discussion piece they can say that it still can happen. For question 2, if the probability of a tornado today is 1/10, would you say that there will likely be a tornado today? Again, students should choose unlikely, but in the discussion portion, they will say that even though it's a small chance, it can still happen. Question 3 asks, if the probability of snow this week is 0.85 or 85 hundredths, would you say that it is likely to snow this week? Students should choose likely, but in the discussion piece, they can also argue that there is a 15% chance that it might not happen. For the Explore, students are going to be presented with the images of 4 different spinners that they're going to be using, and what do they notice about the spinners. Students may point out that they're all circles, that they all include the number 1 in some aspect, that they all include the number 2 in some aspect, that they all include the number 3 in some aspect, and they all include the number 4 in some aspect. Some students might point out that certain spinners have numbers other than 1, 2, 3, or 4, such as spinner A, B, and C. Some students may point out that spinner C is the only one that goes into double digits. Some students may point out that spinner D has 1 as 1/2 of the spinner. Students may point out that spinners A, B, and C, even though they have different numbers, are divided into an equal amount of parts, so on and so forth. For this portion of the Explore, conduct 10 spins with each spinner and record the outcomes for all spinners below. The spinner is linked for you to use in each column. So I highly suggest you doing spinner A as an I do, spinner B as a we do, and having students do spinner C and D on their own. Now I'm going to show you how to demonstrate each of the spinners to your students. This is spinner A for the Explore on Open Up Resources. So simply, students are going to click on spin, or you as the teacher, since this will be the I do, click spin, and you're going to record each of the spins as needed for the I do. If you'd like, you can reset the spinner to be at the 3 o'clock position every time before you spin. This is spinner B for the we do. To make it more of a we do, you can have students let you know when they want to spin it and whether or not they want to reset it. This is spinner C. Students will be spinning this 10 times individually. Remind them to click on spin, and if you want them to click on reset before spinning each time. This is spinner D for the I do portion of the Explore. As with the previous I do, have students spin and record 10 times on spinner D. and remind them, if you'd like, to reset between each spin. Once you're done demonstrating, make sure to record your results and do the same thing for spinner B, so that students are only responsible for recording the results for their individual spins of C and D. Now that students are done, they should have the same spinner A and spinner B results as you, since you did it as an I do and we do. And the only difference should be their spinner C and spinner D result. For part C, students are going to select one of the spinners and they're going to answer questions 1 and 2. This will vary depending on which spinner they chose and what their outcomes were. For part D, they're going to use all of the spinners to answer the following questions. Question 1, do any of the spinners have the same sample space? If so, do they have the same probabilities for each number to result? So yes, spinners A and B have the same sample space. They do not have the same probabilities for the numbers though. For example, spinner A has 2 3s out of 12 equal spaces, so the probability of spinning a 3 is 2/12. Spinner B only has 1 3 out of 12 spaces, so the probability of spinning a 3 is 1/12. For each spinner, what is the probability that it ends on the number 3? Explain or show your reasoning. So spinner A has a 1/6 chance, spinner B has a 1/12 chance, spinner C has a 1/12 chance, and spinner D has a 1/4 chance. The values for spinners A, B, and C are computed by counting the number of 3s on the spinner and dividing by the number of equal sections on the spinner. For spinner B, the section for 3 is 1/4 of the circle. What is the probability that you will spin something other than a 3 on each spinner? Explain or show your reasoning. For spinner A, that will be 5/6. For spinner B, that will be 11/12. For spinner C, that will also be 11/12. And for spinner D, it will be 3/4. Each of these values was computed by counting the number of things that were not the number 3 on the spinner and dividing by the number of sections on the spinner. When Noah spun spinner D, he put it on his closed binder and he never got a 1 in all 10 spins. How might you explain this problem? Students may need a drawing or an image that this is what a binder looks like. And so when they put the spinner on here, the spinner would have been sloped, and so as a result, gravity may have pulled the spinner so that a 1 would not show up ever. And for question 5, when Han spun spinner C, he never got any 3s. So he says that the probability of getting a 3 is 0. How might you explain this problem? So Han might have been holding the spinner at an angle like Noah in the previous problem, or maybe he just did not spin enough times. Since it is possible to spin a 3, the probability should not be a 0. An anticipated misconception for the entire Explorer is that students may think they need to have their probability estimates match the computed probability. Remind them of the activity due for a win to see why we might expect the estimated probability and the calculated probability to be a little different. For the summary, students are going to respond to the question, how can we compare probability estimates based on conducting an experiment many times to the actual probability? You can support students with disabilities by providing a sentence starter so they can focus on the content of their answer rather than on the sentence structure, and then they can complete the cool down. For additional practice, students can do IXL grade 7, II.2, probability of 1 event, the Open Up Resources practice problems, or the Engage New York grade 7 module 5 lesson 2 problem set. This lesson was based off of illustrative mathematics and Open Up Resources, so feel free to look at these materials in order to continue supporting your students' learning. If you have any questions, please feel free to reach out to your virtual content specialist. Thank you.